So welcome to Unit 1 and 2 Maths Methods. So the beginning of the Maths Methods course, or at least for my students, but certainly at a lot of schools, certainly the beginning of the textbook is linear equations and algebra, linear coordinate geometry, and quadratic functions, or depends on the order you do things in, but that's the first sort of three things that start for us. Now, obviously, those are things that, as a Year 11 Maths Methods student, you should be pretty comfortable with. They really form, I cannot stress enough, they really form the bread and butter for this course, and if they are not things that you are very comfortable with, this course is going to be a really, really tough slog for the next 2 years. So for my students, the first couple of weeks will be spent revising this content. I'm not going to do a lot of explicit teaching. This should be things that you've seen repeatedly before now. We'll just be doing a whole lot of practice. And then we'll be having a common test a couple of weeks in to see where you're at with those kind of skills. So there'll be a series of videos here covering each of the skills individually that you can dip in and out of depending on what you need to brush up on and what you need to work on a little more than others. So you might not watch all the videos, you might choose to watch them all, that's completely up to you. Okay, so the first one here is on solving equations and rearranging formulas. So hopefully solving equations should be something we're all pretty good at. This is solving linear equations, I should specify, and rearranging formulas. So personally, I think when you're solving equations, it's important that you are systematic in the way that you approach the equation. So for me, I always look at an equation and think, right, if there's fractions, that's the first thing I want to deal with. I want to get rid of the fractions in the equation, and I'll talk about the way that I would advocate doing that. The second thing would be then to worry about brackets, and the third thing would be to collect any like terms. Once you're at that point, then you should have a very simple linear equation. If we're solving linear equations, then you should have a very simple linear equation, something of the form, 2x plus 3 equals 8 or whatever, or even just 2x equals 8, that is very routine to solve at that point. It's important that you have a routine, otherwise you'll find yourself jumping around and trying to do different things in different orders, and you'll make mistakes when you try to do that. I'll try to highlight a couple of the common errors that you're likely to see. For me personally, working with fractions in equations, now often there's lots of different ways that you can simplify an equation involving a fraction, an algebraic fraction I should specify. And there are different ways, and some are more efficient than others, and they're all equally successful. But I would advocate, again, try and have a process that works all the time. So I would advocate that you should be aiming to write every term in the equation with a common denominator, and then in doing that you can then multiply by the common denominator and hence get rid of your fractions. Right, let's sort of just work through some examples to see that. So solve each of the following equations for x. Now I'm going to try to highlight these two examples illustrate two key errors that I find students make frequently when there's fractions. The first one would be the tendency to go, oh, well, I'm going to multiply both sides by 3. And what you do when you do that is you go, oh, x plus 2 plus x equals 15. And in doing that, you multiplied that thing by 3, and that got rid of the fraction. You multiplied that thing by 3, because, oh, I have to do it to both sides. Yes. But what happened here? This is no longer the same equation. So if you're going to multiply everything by 3, you must multiply everything in the equation by 3. Okay, so it should be 3x equals 15. Now, if you're comfortable and pretty confident and your algebra skills are sound, that's absolutely the perfect first step. But I'm going to add in a step in between that, which means that I do the same thing every time, and I'll get to this equation as well. But it's just important that sometimes you are a bit conscious about what it is that you are actually doing. I'm not saying that you have to do it this way. If you can get straight to that step accurately and reliably every time, fine. But if you are making these kind of errors all the time, add in this step to safeguard that. So again, the thing I mentioned before, write each term in the equation with a common denominator. So this is x over 1 and this is 5 over 1. So the common denominator here is 3. So I'm going to write everything over 3. So we've already got that first fraction over 3. We're going to write this over 3 and the other side over 3 as well. So no changes needed to the the fraction, the first term there. We've got x over 1, so we've multiplied the denominator by 3 to make it 3, so we need to also multiply the numerator by 3, so that's 3x. And again, on the right-hand side of the equation, we've multiplied the denominator by 3, so we do the same for the numerator. 5 times 3 is 15. Now we can multiply the whole equation by 3. I know people are very fond of, cancelling things. I'm a bit hesitant about the word cancelling. I think sometimes people do it without knowing what they're actually doing. Technically what we're actually doing here is multiplying both sides of the equation by 3, but honestly you don't need to write anything. I find students that kind of do a lot of this sort of, I'm going to times everything by 3, you end up with things that aren't mathematically correct written on the paper. For example, here on the left-hand side, if I've written those little times 3's to indicate I'm multiplying both sides by 3, and so then I'm going to get to x plus 2 plus 3x equals 15. The problem here is, in terms of sort of order of operations with no brackets, you're really technically only multiplying that by 3. Just don't write anything. Just do it. You don't need to signpost, now I'm multiplying both sides by 3, now I'm adding 5 to both sides. Just do it. Multiply everything by 3, that's where we get to. Next thing we need to do is collect like terms. X plus 3x is 4x, plus 2 equals 15. Subtracting 2, 4x equals 13, dividing by 4. So x is 13 on 4. As long as it's a simplified fraction, which it is, and by that I mean there's no common factors between the numerator and denominator, there's absolutely no need to write that as a mixed number. There's no need to write that as 12 1/4 or 12.25. It's perfectly fine to leave it as 13 on 4. Okay? The less steps you do, the less opportunities there are for you to make mistakes. There's no need to. One of the things that the VCAR examiners commonly say in the examiner's report is don't engage further with the question than is necessary. Okay? So if you've answered the question, which we have at this point, stop. Done. Okay, part B, another equation involving fractions. So the first thing I'm worried about is that. Again, I'm going to use my strategy of expressing everything in the equation with the common denominator. Just going to write a bit, just if you're writing on paper here, I haven't really left quite enough space here, so just be mindful of that. So the common denominator here is going to be 10. So we're writing everything over 10. So the first fraction, the denominator has been multiplied by 5, so we'll multiply the numerator by 5. The second fraction, we've multiplied the denominator by 2, so we'll multiply the numerator by 2. And the third fraction, we've multiplied the denominator by 10, and so we'll multiply the numerator by 10. Now at this point, we can multiply everything by 10, get rid of the fractions, and we're at this point. Minus 2. Now, I've made a really conscious decision here about not expanding out those brackets on the numerator as I did them. I deliberately wrote them with brackets, and I've deliberately not expanded them out at this point, because this is the common error that you'll make. If you had expanded it out up here, you would have got, 4x minus 2, and here you would have 4x minus 2. Okay, and the first one as well, fine. This would be 5x plus 1. 5x plus 5, sorry. And 5x plus 5. And at this second line here, you've made a mistake, because what you've missed is that this minus here means that you are subtracting that entire numerator. And so, when you drop the denominators, when you multiply everything by 10, there must be brackets there. Okay, you could put brackets here as well, but that's not an issue in the first fraction. It's this minus here that's an issue. If you're adding, it doesn't make any difference to put the brackets around it. So if this was this problem, you would inadvertently get the question right by just doing that straight away and not really thinking about the fact that it's all of that, which is why I'll almost always make it a minus if I'm trying to assess this in a test. So it's really important that you're careful about that. I find that if you don't expand, that it's easier for students to avoid the error by not expanding out the brackets until after they've got rid of the fractions. So, as I said, we had 5 times x plus 1 up here, and we have 2 times 2x minus 1 down here. Sorry, I may have expanded that out incorrectly before, but anyway, made the same point. So then don't expand it out at this point. Wait until you've got no fractions before you then expand it out. Because what you'll find is very few of you will make the mistake of ignoring the negative when you expand out that bracket, whereas almost all of you, or the majority of you, will make the mistake of losing the negative if you don't bear in mind that the whole numerator needs to be made negative. Okay, so now I'll expand out my brackets. 5x plus 5 minus 4x plus 2. This is where you'll have made the mistake. You'll have a minus 2 there if you expanded earlier and then you weren't careful about what happened when you got rid of the fractions. Okay, collecting like terms. 5x plus, minus 4x is x, 5 plus 2 is 7, equals 20, and so x equals 13. Okay. So I know sometimes students sort of think, oh, I've got to write so much here, but it's worth it. You can treat each term separately, focus on getting that common denominator first, and after that it's smooth sailing and easy. Okay, you can do a whole lot of other shuffling of things around that ultimately will end up with more work. Invest the time in that first line and then it gets easy very quickly after that. Make sure you know how to solve equations using your CAS, menu 3.1, type the equation in, comma, and then list whatever variable it is that you're trying to solve for. If you've got fractions, control divide, control divide brings up a fraction template, can be a quick and neat, easy way to enter in, expressions like this. Can help you avoid, having to think about where does there need to be brackets, etc., etc. Okay, solving literal equation. So a literal equation being an equation where you haven't got numeric coefficients, you've got letter coefficients or variable coefficients. Also formulas. Generally speaking, a formula tends to refer to something that actually represents, a equals pi r squared or something is actually a known formula. If it's just a random collection of letters and letters that we're trying to get you to rearrange, literal equation. But anyway, so the key thing is that this will really test whether or not you actually know what you're doing when you're solving equations. And if you don't know what you're doing, if you just randomly move things from side to side without thinking about the maths behind those steps, you'll find you'll struggle with these kind of things. What you need to be able to do is think about the fact that if I can solve this problem where there were letters in place of the numbers, then I can solve this problem with letters. Sorry, where there were numbers in place of the letters, then I can solve this problem with letters. So for example, if you can solve that equation, 2x minus 3 over 5 equals 7, and you know, oh yeah, I multiply by 5 and then I add 3 and then I divide by 2, then you can also solve this and know, okay, I multiply by C, I add B, and then I divide by A. It's exactly the same. It's helpful, I think, to think about if you can't make that decision quickly, like the list I just gave then, you need to be able to think about what's really important in equation solving is your order of operations, BODMAS, or some people might refer to it as BIDMAS, or there's also PEMDAS. There's slight variations depending on what you use. I was always taught BODMAS, but I think BIDMAS is better because the O in BODMAS is not of, it's I for indices. Okay, powers happen there, which is why PEMDAS is parentheses instead of brackets, exponents. Okay, we could go with BEDMAS, exponents. But being clear about what's the order of operations, so being able to deconstruct an expression. How is this, what's happening to x? What's the order of the things that are happening to x in constructing this expression, and then how do I undo them? So if you're looking at this, if that expression's been built up by starting with x, the first thing happening to x there is the multiplying by 2. Okay, multiplication happens before the subtraction by 3, which then happens next. And then technically it's the reason we didn't do the divide by 5, because division happens before subtraction, is because actually this line in the fraction is meaning brackets. So we're doing the brackets first, which mean we do the multiply by 2, then the take away 3, and then we're dividing by 5. So in solving, we're doing those same things, but we're undoing those things in the reverse order. So the opposite of divide by 5 is to times by 5. Then add 3, and then divide by 2. Okay. I would write that list out if you are not very good at rearranging equations, okay? Particularly formulas. Most of you will be able to do it more intuitively when they're numbers, but you don't make that leap as easily to the letters in the formulas and literal equations. Okay, anyway, let's get into some examples. So solve for x, part A. A equals b plus cx squared all over d squared. Okay, focus on x and focus on what is happening to x to construct this expression on the right hand side, and therefore then you can think through what needs to be done to undo it. Okay, so here's x here, in there. Alright, so the expression, and when I talk about the expression, I'm not worried about the a on the right-hand side. It's just going to sit there while we do things to it. I'm worried about how we've constructed the right-hand side. So the first thing that's happened to the x is that it's been squared, so power of 2. Okay. The next thing that's happening to the x, because let me put my bid mass back up here. Okay, the fraction means that we're dealing just with the numerator things first, and the first thing happening to x is the indice, the power, index, sorry. Then the next thing is the multiplication by c. Then the next thing is the addition of b. Then we worry about, we've dealt with the brackets, which were essentially there, and the last thing that's happening outside of the brackets is to divide by d squared. Sometimes people get stressed about the fact that there's a squared, or I've got to take a square root. There's no, okay, the x is being squared, there will be a square root later on, but we don't need to take a square root to deal with this. In terms of the impact d squared is happening on x, it is dividing x. Okay, so the first thing we need to do in order to get x on its own is to do the opposite of dividing by d squared, which has got nothing to do with square rooting. The opposite of dividing by something is to multiply by that thing. So we're going to multiply by d squared. Multiply both sides of the equation by d squared, we get ad squared equals b plus cx squared. The next thing we want to deal with is the plus b, and the opposite of that is to subtract b. So we're going to subtract b from both sides, and we get ad squared, take away b, and we're left with cx squared on the right hand side. The next thing we want to undo is the multiply by c, so we're going to divide both sides by c, and that means we're going to get ad squared minus b all over c equals x squared. And then the final thing is to undo the squared. The opposite of squaring is to square root. So we're going to square root both sides. When we take a square root, it's really important, when you take the square root, you get a plus minus. So unless there was something here telling us that x has to be a positive value, which there isn't, x is going to be equal to the positive or negative square root of ad squared minus b all over c. Okay, let's have a look at b. Now b is slightly different. I'm not going to launch into this process straight away. I'm going to wait till I've got my equation a bit more simplified before I do that. The first thing I'm identifying here is I'm trying to solve for x, and there are two x's in the equation. There's also fractions. Okay, so same process we thought about with the equations earlier. Deal with the fractions, expand any brackets, collect any like terms, and away we go. So the first thing I'm worried about is the fractions. Now, technically, if we take my original strategy, we write everything in the equation with a common denominator. Now, if I do that in this step, and this is why I advocate this, it works every time, but it's probably, in this instance, I probably wouldn't bother to write out this line, but I'm going to show you what's actually happening, because a lot of you use a technique without really thinking about what it's doing. And actually what it's doing is finding a common denominator and multiplying by that common denominator. Okay, so we've got two different denominators there. The easiest way to find a common denominator is to multiply them together. So the common denominator is going to be x plus n times x plus m. Okay, so thinking about what we did on the left-hand side, we've multiplied by x plus m. So we do the same to the numerator. And again, I'm not going to expand out the brackets till after. On the right-hand side, we've multiplied the denominator by x plus n. So we're going to have b times x plus n. And then we can multiply through by that common denominator, and we're just left with the numerators. Now, in this case, because there was no subtraction, you wouldn't have had any issues if you'd expanded out the numerators straight away. And equally, what some of you will be screaming at me is, why didn't you just cross-multiply? And yes, cross-multiplying works in this instance. The reason I don't like the phrase cross-multiply is because I find students do it in cases like, sorry, I thought it was going to be a good example up there. Let's say I give you, x plus 5 over 2 equals x over 3 plus 7, and they go, oh, we'll cross-multiply and we'll get 3 times x plus 5 equals 2x. And you haven't done anything to that. You're not thinking about the maths of every time you do something to an equation, you've got to be able to understand what is it that I'm doing to both sides. Okay? Actually, so if there was no plus 7 here, yes, this would be perfectly fine. Because what you're doing is you're multiplying both sides of the equation by 6, which is the common denominator. Multiplying this by 6, the 6 cancels down with the 2 to leave 3 times x plus 5. Multiplying the right-hand side by 6, the 6 cancels down with the 3 to leave 2 times x. Okay, it is still about common denominator and multiplying by the common denominator. So, you know, again, if you're frequently making errors, take the time to write it out with the common denominator and then you're done. Okay, so now we've got brackets. Let's deal with those. AX plus AM equals BX plus BN. Okay. Next, again, it's about keeping focused on what you're trying to do. You're trying to solve for x. Okay, so we actually still have two x's in this equation, so that's our next problem to address. So I'm going to focus on getting the x terms on the same side. So I'm going to write ax minus bx, and I'll just move the other things onto the other side. So subtracting am from both sides leaves us with this. Okay, so now we've got the x terms on the same side. We need to focus on what we can do here. And the key thing is, now if you had this equation, let me give you this. Let's make it 3x plus 5 equals x. No, I'm just going to make that number bigger. 7x, and let me make this 3x minus 2. Okay, if we had this equation, you all know how to do it. You get the x terms on the same side, so it becomes 7x minus 3x, subtracted 3x from both sides, and subtract 5 from both sides. Okay, and then you probably wouldn't have bothered to write out that line. You would immediately just simplify that to be 4x equals negative 7, and then x equals negative 7 on 4. Okay, now when we collect like terms, when we make 7x minus 3x equal 4x, remember they're like, the only time we can subtract them is if they're like terms. If that was 7x minus 3y, they don't subtract. The reason like terms is important is because actually what we can think about as happening here is we're identifying that x, that like term, is the common factor. And when we take out x as a common factor, we get left with 7 minus 3. So we get 4 lots of x. And so it's the same idea here. Okay, x is the common factor. We take it out. We're left with a minus b. Okay, and that's what we've got. And now, in having done that little step of factorization, we now have only one x in our equation. We now want to think about what do I need to do to get that x on its own. So we have to think about what is happening to the x and how do I undo it. So there's only one thing happening to the x. It is being multiplied by this bracket. We're not taking b away from x, we're taking b away from a, and then we're multiplying that by x. So we need to divide by a minus b, and so x is, so I'm just going to write a bit small, in fact I might write over here. X is going to be bn minus am over a minus b. Okay. Nothing cancels down here. There's no common factors in the numerator, so it can't be simplified any further, and therefore there's nothing that we can divide that's in common with both the numerator and denominator. Okay, last one here, c. Let's make a the subject in 1 over a minus 1 over b equals 1 over c. Again, we've got fractions. Let's focus on getting rid of the fractions first. Then we'll worry about how we're going to get a on its own. So, common denominator. Common denominator here is ABC. First fraction, we've multiplied the denominator by BC, so we'll do the same to the numerator. Second fraction, we've multiplied the denominator by AC, so we'll do the same to the numerator. Third fraction, we've multiplied by AB, same to the numerator. Now we can drop the denominators because we're multiplying everything by ABC. And now we focus on what we're trying to do. We're trying to make a the subject. Okay, so let's get the a terms on the same side. So I'm going to add the AC onto the right hand side. And then we can do the same thing that we did in the previous question. So we identify that a is a common factor on the right hand side. So it is a times b plus c, and then we can divide by b plus c. So a will be equal to bc divided by b plus c. Okay, using your CAS to rearrange formulas is just solve. Okay, you just need to be careful though when you use your CAS when you're working with formulas. So let's say, for example, let's have a look at this one up here, this formula up here. If we get our CAS to solve that for x, so menu 3.1, menu 3.1, solve. Now, you can use that fraction template I talked about before, control divide, to help you set it up. Ax minus b over, something's not, my touch is not quite working, let's try again. Control divide, ax minus b over c. I've lost the solve, haven't I? Menu 3.1, control divide, ax minus b over c equals, and hopefully many of you are shouting at the error that I've made here. I want to solve that for x. My CAS is going to do this, which hasn't solved for x and has given me something slightly strange looking. And this is one of the most common fundamental things you need to know when you're working with your CAS. Okay, your CAS, in this instance, you'll see when I pressed enter, let me just make this a slightly different thing. If I had written, if this was a number and I'd written 2x minus b over c, when I press enter here, have a look at watch what happens with the 2x the minute I press enter. The CAS automatically adds this dot between the 2 and the x, which is multiplication. It understands when I write 2x that I mean 2 times x, okay? And so it can then solve that for x. Up here, when I hit enter on the ax minus b, it didn't insert the multiplication in between the a and the x. It didn't understand that I mean a times x, and what it's seeing is that there is a single variable that's called ax. Okay, so it's not differentiating the a and the x as being separate variables. It allows me to use words as variables. So it's saying that this equation involves a term called ax, b, a c, and a d. And so therefore, when I'm asking it to solve for x, there is no x in the equation as far as it's concerned. So when you have two non-numeric, non-number, two letters, letter bracket letter, you need to be explicit about where the multiplication goes. And now it'll rearrange it to solve for x. So that's the main thing you need to be careful about when working with formulas. Make sure that you are explicit about your multiplication between two non-numeric characters. Okay, working with formulas, so just simply basically substitution problems. Very simple in principle, but these questions are still good to practice because often they will really force you to, practice your number skills. And I cannot stress how important it is that you've got good number skills, fractions, decimals, etc. Please don't underestimate the level of number work that you'll be expected to do in exam 1 next year. So when you don't have any technology available to you. So you do need to be able to be quite flexible when working with numbers. So let's just have a look at 2 examples here. Find the volume of a cone with a base radius of 4 centimetres and a height of 12 centimetres. So this assumes that you know the formula for a volume of a cone. On the standard Maths Methods formula sheet, there are a few of the measurement formulas, and I think from memory volume of a cone is on there, so you would be able to refer to this. But volume of a cone is 1/3 times the volume of a cylinder, and the volume of a cylinder is pi r squared h. Okay, so we want the volume with a base radius of 4 and a height of 1.2 centimetres. So volume is 1/3 times pi times r is 0.4 squared, and h is 1.2. Okay, there's lots of different ways you could go about this. You've got both decimals and fractions here. I strongly advocate that fractions are much easier to work with than decimals because they're essentially whole numbers, okay? If you're trying to do 1/3 times 5/7, it's all just whole number maths. 1 times 5, 3 times 7. It's just about knowing how fractions work. So generally speaking, it's whole numbers. So you might choose to instead write 0.4 as 2/5 and 1.2 as, what's that going to be, 6/5. If you don't know how to get it to 6/5, multiply it by, at the moment it's 1.2 over 1, so make it 12 over 10 by multiplying the top and the bottom by 10, and then simplifying that fraction gives you 6 on 5. Okay. Similarly here, 0.4 is 4 on 1, multiply top and bottom by 10, it's 4 on 10, which simplifies to 2/5. Okay. That level of fraction manipulation needs to be pretty comfortable for you. The reason I say that is because for many of you, 2/5 squared is much easier than 0.4 squared because it's squaring whole numbers. It is 2 squared, which is 4, over 5 squared, which is 25. Great. Okay, however, if you are comfortable, and also because I've got another fraction here, then I'm going to be able to put all those together. However, in this case, and I generally go for fractions, I probably wouldn't in this case at the moment because I'm seeing that the 1/3 and the 1.2 are going to play nicely together. Because 1/3 of 1.2, if I can work out what a third of 12 is 4, then 1/3 of 1.2 is 0.4. Okay, so if we put together the 1/3 and the 1.2, we're going to have pi times, I'll talk about the 0.4 squared in a second, it's going to be 0.4. Okay, and so then actually you might want to think about, well, actually I've got 0.4 cubed. Really, haven't I? Alternatively, if you don't, and then you can work out, if you know what 4 cubed is, you can work out what 0.4 cubed is. Alternatively, you can just do 0.4 squared, which is essentially just 0.4 times 0.4. Now, if you really just want to think about it as 4 times 4, okay, and then a quick shortcut way is if the original calculation has 2 digits after the decimal place. And by that I mean 2 significant digits. Obviously we could write lots of zeros here, but they're not significant. 2 digits after the decimal place, then your final answer should have 2 digits. So 4 times 4 is 16. Sorry, your final answer should have 2 digits after the decimal place. So this answer is going to be to do with 16, but it needs to be written so that there's 2 digits after the decimal place. So it's not going to be 16.0. It's not going to be 1.6. It's going to have to be 0.16. Okay? 0.16. And then you can do that times 0.4. If you preferred to think about this as that was going to be 0.4 squared times 0.4. So if you think about this as 0.4 cubed, okay, alright, well 4 cubed is 64. Remember 0.4 cubed is essentially 0.4 times 0.4 times 0.4. Okay, now I know 4 times 4 times 4 is 64. So my original calculation here has 3 digits after the decimal place. So I need to write 64, so it's got 3 digits after the decimal place, which means I have to put a 0 in here. It's 0.064. So 0.064 times pi. As I said, if you're not comfortable working with decimals, and I'm less comfortable working with decimals than I am with working with fractions, write it all in fractions. It's a third times pi times 2/5 squared times 6/5. So it's a third times pi times, as I said, that was 4 on 25 times 6 on 5. And again, simplifying where you can, I might cancel that 6 and that 3 down. Okay. So actually what we've got here is pi times 4 times 2 on the numerator there, 8, and 5 times 25 is 125. So it's 8 on 125 pi. Or 8 pi on 125, same thing. Okay. So working with decimals and fractions, all of that are absolutely things that you need to be able to do and feel comfortable with if you're going to succeed in maths methods. You'd hate to master all the new and difficult content over the next 2 years and then still be falling down every time you have to work with decimals and fractions. Okay, and the last example here, find b if a equals b minus c over d, and a is 0.6, c is -2, and d is 1/4. Now if you want, find b, you could rearrange the formula first to make b the subject. Personally, I'd prefer to put the numbers in first and then simplify it after that, but either way should work, as long as you work accurately. So subbing in for a is 0.6, b is what we're trying to solve for, c is -2, all over d, which is 1/4. Okay, so a few things to deal with here. 0.6 minus minus, that's b plus 2. Dividing by 1/4, let me write that out in a different way. We're dividing by 1/4. When you divide by a fraction, some of you might recall that it's the same as multiplying by the reciprocal of that fraction. So actually dividing by 1/4 is just multiplying by 4. So we've got 4 lots of b plus 2. 0.6 is 4b plus 2. Now, a couple of different things you could do here. You could take away 2 and work out that that's going to be -1.4 equals 4b, and then divide by 4. b is -1.4 on 4, and you cannot leave a decimal in a fraction. This is just an unsimplified fraction. So, multiply top and bottom by 10 to get rid of the decimal. So that would make it -14 on the numerator, 40 on the denominator, and then simplify. 2's a common factor, so -7 on 20. Alternatively, another option would have been, back here, you could have multiplied the whole equation by 10 here. So you get 6 equals 40b plus 20. Take away 20 is -14 equals 40b. Divide by 40. And then simplify. Okay? Whatever you're comfortable with, but it's important that you can work flexibly with decimals, fractions, and potentially in quite complicated arrangements like that. Okay, good practice here. Exercises 1A and 1F is going to review your linear equation solving skills and your rearranging of formulas, which are essentially all the same thing, just whether there's numbers in the equation or letters. That's what we've got there. So there's a sorted list of questions. By all means, do more of the things you're not good at. You know, do a few less of the things that you're pretty comfortable with at this point. The whole aim of these early parts of this course is to make sure that wherever you're at with linear equations and graphs and with quadratic the basics of quadratics, that you can brush up on that. So make sure that you're not wasting time doing lots and lots of questions of things you're already really good at. Push yourself and make sure that you are practicing the hard things that you don't really understand. Ask questions, make sure that you're improving. Okay. Best of luck. The next video will continue on looking at this revision of linear functions and linear algebra.